All right, let's look at transversals and parallel lines. At the top of the page, these lines are clearly not parallel to one another. So we have two lines. If I draw another line that crosses these two, I have drawn a transversal. This line is a transversal. A transversal is just a line that crosses two or more lines. Okay, so that's the definition of a transversal, and this is an example of a transversal. When we do that, we form 8 angles. At this intersection point, I have angles 1, 2, 3, and 4. And at this intersection point, let's number these 5, 6, 7, and 8. We're going to be looking at pairs of angles and just coming up again with more vocabulary words and geometry. So corresponding angles are in the same position. And there are 4 pairs of these. 1 is in the upper left spot, 5 is in the upper left spot in both of these at both intersection points. So angle 1 and angle 5, that's a pair of corresponding angles. Likewise, so are 2 and 6. 2 is in the upper right, 6 is in the upper right. 3 and 7 are both in the lower left position. And then 4 and 8 are both sitting down here in the lower right position. So that's what it means to be corresponding. When you draw the transversal and it crosses 2 lines, you're going to have an interior portion and an exterior portion. So this is the interior, and then everything out here, exterior and exterior. So alternate interior angles, clearly they have to be inside. They're going to be on opposite sides of the transversal, kind of as far away from each other as they can get and still be inside. So there are only 2 pair of these. We have angles 3 and angle 6, and then we have angles 4 and angle 5. That's my pair of alternate interiors. And the same reasoning can be applied for alternate exteriors. They're going to be on the outside on opposite sides of the transversal. So we have angle 1 and angle 8, and then angle 2 and angle 7. Okay? And then the only other type, and there again will be 2 pair of these, consecutive means one right after the other. These are going to be on the same side of the transversal on the inside. So one pair of consecutive interiors would be angles 3 and angle 5, and then the other would be angles 4 and 6. So that's just getting us used to the vocabulary. Now I want to explore a scenario when I have parallel lines. And this symbol here, this symbol is the symbol for parallel, okay? So I'm going to use my ruler and force a pair of parallel lines. Okay, so with my ruler, if I hold it steady, I know that the opposite sides run parallel. So these 2 lines are parallel, and we can show those by marking them kind of with an extra pair of angles, of arrowheads there. And then I'm going to draw a transversal. So when I draw that transversal, let's number them the same way. Let's see what's true of these angles, starting with our corresponding angles. So I'm going to use a piece of patty paper, and I'm going to trace angle 1. This is 1. 1 corresponds with 5. And if I come down and look, those are equal in measure. Let me try a different one. Let's try angle 3. Angle 3 corresponds with angle 7, and those are equal in measure. And that's true for all corresponding angles. They're going to be congruent to one another. What about alternate interior angles? So we know that 3 and 6 are a pair of alternate interior angles. I've already traced 3, and if I turn my paper around, I can see that 3 and 6 are exactly equal to one another. Let me just go ahead and trace 5. So angle 5, that's an alternate interior with 4, and I can see that it also is a perfect match. Okay, so 5 and 4 are congruent. And then let's go ahead and see what's true of our alternate exterior angles. So 1, which I've already traced, is an alternate exterior angle down here with 8. Those are congruent. And I haven't traced 7 yet. Let's do that one real quick. If I trace angle 7, 7 is an alternate exterior with angle 2, and I can see that those are congruent to each other. So all 3 of these angle pairs, when formed by parallel lines, these are always going to be congruent. So you might remember that there's one other angle pair, and these are consecutive interior angles. So 3 and 5. So I've traced both of those angles. So here's angle 3 that I traced. If I bring 3 down to 5, and you can see that angle 3 doesn't fit there perfectly with angle 5. But there is a relationship between them. So here's what I'm going to do. I'm going to take angle 3 and I'm going to copy angle 5 onto it. So there's 3. We knew 3 was congruent to 7 down there. And I'll trace angle 5 like such. Here's 5. If I take that paper away, you can see that angles 3 and 5 make a linear pair. If you think about it, we knew that 3 was congruent to 7. So if 7 and 5 make a linear pair, then it would stand to reason that 3 and 5, while they don't form a linear pair, they will be supplementary. They're going to add up to 180. All right, so consecutive interior angles, these are supplementary. Supplementary, they add to 180 degrees.